Faster, Jack. Get down. Well, Jack, now you're a little bigger than a human cell. But at least you escaped the Grim Reaper for now. You do understand that you can't run away from death, right? Sooner or later, it will take its toll anyway. People age, and our genes are to blame for this. At the ends of human chromosomes, there are special tips that protect the chromosomes from damage. They are called telomeres. Telomeres shorten over time, and when they become too short, our limited supply of stem cells stops dividing and replenishing the lost cells. Stem cells are the precursors to all other cells in our bodies. They can turn into any cell and repair damaged tissue. Basically, stem cells are like children who have not yet chosen their future profession. Old cells do not perform their functions, but take up useful space in our body. Basically, they become a cellular analog of zombies, dead people poisoning our body with toxins. Fortunately, scientists have already found a way to cleanse the body of these zombies. Senolytic drugs, like a special forces unit, find and destroy dead cells. Older mice that were injected with senolytics became as active as young mice. Their hearts worked better, and their endurance increased. However, senolytics are a symptom-based treatment. Is it possible to eliminate the very cause of aging, the shortening of telomeres and the reduction of stem cells? And the answer is yes, it is. Scientists are currently experimenting with the protein telomerase, which is capable of restoring damaged telomeres. Experiments on mice have shown that taking telomerase can not only extend the life of rodents by up to 40%, but also cure age-related diseases such as myocardial infarction and dementia. Scientists are conducting experiments with reversing the life of cells. The main danger here is not to get carried away and not to turn viable cells back into stem cells. In addition to telomere shortening, there is another cause of aging, NAD+ deficiency. This substance is responsible for converting food into energy for the cell. Our body is very reluctant to produce NAD after 30 years. Basically, the NAD is the battery of our cells. Like any battery, it discharges over time. The good news is that it can be recharged. Using special drugs, scientists were able to restore NAD levels in mice. As a result, the muscles of the experimental mice returned to their youthful shape. Hooray, Jack! You're back to your former height. Look out, behind! The key to a long life is lifestyle, and, in part, genes. The officially registered record for life expectancy was set by Jeanne Calment. She lived 122 years and 164 days. She met Van Gogh in person and survived 2 world wars. When she was 90, her personal lawyer made a deal with her that he would receive her estate if she died first. Jeanne outlived him by 2 years and died on August 4, 1997. Can you, Jack, achieve the same result? I doubt it. Hours spent playing video games are not in your favor. Now scientists are starting to test drug-based life extension methods on humans. Such drugs are terribly expensive, which raises questions of social inequality when the rich will be able to live much longer than the poor. Who knows? Maybe soon the level of medicine will grow so much that anyone will be able to afford a longevity pill. In the meantime, run, Jack, run! Sports prolong life.